Okay, so I'm continue with section 3.1. We stop on problems. The video one, the lecture one was we stop on finding the domain. So I gave you many examples, 4 different examples, but also I gave you many notes how you're going to find the domain of different types of functions. Here also on the PowerPoint, which is provided, I'm listing 3 major steps how to find the domain of function defined of the equation. So step 1, start with the domain as the set of all real numbers. If the equation has denominator, exclude any numbers that gives a 0 as a denominator. So here I'm talking about all the equations which have fractions, you make denominator not equal to 0. If equation has radicals of even index, square root, exclude any number that cause expression inside the radical to be negative. So what that means here, that when you have radicals with even index, you take the expression you take that expression under radical, and we have to give the condition that has to be 0 or greater than 0. Okay, and I gave you also information that the radicals with at index, the domain, it's all real numbers. Okay, here. Next, we're going to talk about difference, product, and quotient of functions. So here we have the definition of the sum. This definition tells you that we have 2 different functions, f and g, with 2 different equations. And to find the sum of function f plus g, we need to add the equation of those functions together. So sum of function f plus g, it's equal function f plus function g. Difference of 2 functions, so difference f minus g of x, we call it difference of f and g. You're going to find the difference of 2 functions. So you're going to take equation of function f, because that's the first one, and you're going to subtract function g from the first equation. Product f and g, so what you're going to do, you have 2 different functions, f and g, and to find the product, this formula just tells you that you will need to multiply the equations of those 2 different functions together. And for difference, which we call, not difference, for fractions, which we call quotient of f and g, you're going to take the function f, which will be in the numerator, and divide, which means create the fraction, by the function g. With the quotient, we're going to do some extra work because we'll need to rationalize the denominator. And technically, that's it from the definition of the section. The rest is just the examples. So here we have one problem which we need to finish. We have 2 different functions, function f and function g. And for those 2 functions, find the following functions. So in part A, we need to find sum. In part B, we need to find difference. C, we need to find product. D, we need to find quotient. And find the domain in each case. Okay. So let's start. What I'm going to do, I'm going to show work using my whiteboard. So I'm going to do the first one. So we have again f of x, it's equal 1 over x plus 2. G of x, it's equal x divided by x minus 1. Okay. And we have to find a, they ask you to find f plus g of x, which means sum. So using the definition, that means we adding equations of function f and equation of function g together. So in our case, the sum of two functions f plus g of x equal, I copy equation function f, which is 1 over x plus 2, plus function g, which is x over x minus 1, and we adding them together. Now, what happened here? You have fraction plus fraction, so you need that common denominator. So common denominator, when you have fraction plus fraction, you take the expressions of both denominators and you multiply them together. So it will be x plus 2 times x minus 1. So what I'm doing now, I'm building equivalent functions having a denominator x plus 2 times x minus 1. So my original fraction, which is 1 over x plus 2, to build that common denominator, I multiply top and bottom by this fraction by the denominator of the second fraction, which is x minus 1, x minus 1, plus I'm taking the second fraction, which was x over x minus 1, and I need to build that common denominator. So this fraction, I multiply top and bottom by the denominator of the first fraction. So we'll multiply by x plus 2 times x over x plus 2. Okay, so let's simplify that. So we have 1 times x minus 1, which is just x minus 1 over x plus 2 times x minus 1, plus here I have x times x plus 2. So let's distribute that. That will be x squared plus 2x over x plus 2 times x minus 1. And now what happened here, we have common denominator. So copy the denominator, just x plus 2 times x minus 1, and add numerators together. So we have x minus 1 plus x squared plus 2x, and that will give us x squared plus 3x minus 1 over x plus 2, x minus 1. So here, just going back, I know that but the final answer of f plus g of x is x squared plus 3x minus 1 over x plus 2, x minus 1. Okay, so that's the sum. They also ask to find the domain of f plus g of x. So what happened here? The final function has a fraction. So what you guys know about finding the domain of the fraction. So you need to take the numerator and it can be equal 0. So that will be x plus 2 can be equal 0, x minus 1 can be equal 0, which means x cannot be equal negative 2, x cannot be equal 1. So the domain is the set of all x such that x can be equal negative 2, x can be equal 1. Okay, so that's the final answer, but overall, to find the domain of combination of the function, you always have to find the domain of f in domain of function g. So that's what I'm going to do in the second one, okay? And you combine them together. Okay, let's do B. In B, they ask you to find the difference. So you guys don't want to do your work twice because look what happened. In part A, we find the sum when we add f plus g two equations together. And we did that by creating common denominator. So the only difference it's going to be that when we find the difference, you're going to have a minus here. And you're going to have a minus here. So I recommended to copy this part. Doesn't want to copy. So, but let me copy that. So that was, again, x minus 1 over x plus 2, x minus 1 minus x squared plus 2x. Okay, so again, going back, since we did that work, so I just copied this part and I replaced plus with minus. So now we have common denominator. You're going to copy this down. So this is x plus 2 times x minus 1. And you subtract in numerators. Just be careful because you subtract the expression. So I recommended to keep that in parentheses. So this is x minus 1 minus x squared plus 2x. So we're going to distribute that minus. So that will be x minus 1. Negative 1 times x squared, it's negative x squared. Negative 1 times 2x, it's negative 2x over x plus 2, x minus 1. And that will give you negative x squared minus x minus 1 over x plus 2, x minus 1. So that's the difference. This is f minus g of x. Okay, f minus g of x. And also they're asking you to find the domain. So find domain of combination f minus g of x, okay, means find domain of f of x, find domain, because before I just used the shortcut, so find domain of g of x and combine them. And combine them together. So going back to function f of x, just want to show you guys that originally the f of x was 1 over x plus 2. So domain here, it's x plus 2 cannot be equal 0. So x cannot be equal negative 2. G of x originally have equation x over x minus 1. So the domain of g of x is x minus 1 can be 0. X cannot be equal 1. So the domain of f minus g of x is all the x's such that x can't be equal negative 2, x cannot be equal 1. Okay, so this is set builder notation. If they will ask you to use interval notation, if you want to graph it, so our x's, we can pick any x's except negative 2 and 1. So the domain, like you see using interval notations from negative infinity to negative 2, union negative 2, 1, union 1 to positive infinity. So this is interval notation. So the same solution, but written different way, okay? And again, going back, like you guys see, that definitely makes sense because you have x plus 2 and x minus 1 in the denominator. So we cannot make them equal 0. They cannot be equal 0. The third part was C. When we have to find the product, f times g of x. So what you're going to do, you're going to multiply equation of function f, which is 1 over x plus 2, by equation of function g, which is x over x minus 1. And now you have fraction multiplied by fraction, so you multiply top with top and bottom with bottom. So that will give us 1 times x over x plus 2 times x minus 1. So 1 times x, it's x. Here we FOIL. So x times x will give us x squared. And I'm just checking how they left that product. You know what? They didn't FOIL. So I'm not going to FOIL either. And they left this function in a textbook as x plus 2 times x minus 1. So this is the product. So domain of f times g of x consists is the domain of both f of x and g of x of both function. So domain of function f, it's right here. All the x's which cannot be equal to negative 2, domain of function g are x not equal 1. So domain of that product will be the same thing, all the x's such that x cannot be equal negative 2, x cannot be equal 1. Okay, so that's the domain. If they will ask for interval notation, you guys will use the one which we have above. That's the interval notation. And the last one, let me show you how to find quotient. Quotient has a little more work. So we have f over g of x. So we're going to divide fractions together. So copy equation, that means you have function f of x and you have to divide by g of x. So let's copy the equation of f of x, which is 1 over x plus 2, divide by g of x, which is x over x minus 1, and you have fraction divide by fraction, which I like to call keep, change, flip. Okay? Keep, change, flip, which means keep numerator the way it is. So we have 1 over x plus 2. Change stands change division to multiplication. And my shortcut flip stands flip the denominator, which means multiply by reciprocal. So we have x minus 1 over x. And now instead of division, you have multiplication. So we know how to multiply fraction by fraction. You multiply top with top and bottom with bottom. So we have 1 times x minus 1 over x plus 2 times x. So that will be x minus 1 over x times x plus 2. And I noticed that the answer they didn't, that's how they left the quotient. Okay, so only with quotient, you guys need to remember when we have to find the domain of any quotient. So is the domain of both f and g also give additional condition okay, also give additional condition the denominator of your final product not equal to 0. Denominator of your solution. Okay, so this is what happened here. So only with quotient, we know the domain of function f of x. So again, function f of x was 1 over x plus 2. We know the domain of this function was x cannot be equal negative 2. We know domain because we find it before of function g of x. Function g of x is x over x minus 1. So domain of this function is x cannot be equal 1 because when x is equal 1, that makes this function, we cannot solve this function because in the denominator you have a 0. But look what happened. Our final solution right here for a quotient, we have this x times x plus 2. So this is my extra condition that f over g of x, the final answer was x minus 1 over x times x plus 2. So here you have to also give the condition that this denominator, x, and x plus 2, it's not equal to 0. So how you solve that? You're saying that x can be 0, x plus 2 can be 0. Okay, so you have to combine all of them together. So x plus 2 not equal 0 means that x is not equal negative 2, which I already have it. X cannot be equal 1. And don't forget, this is extra, that x also cannot be equal 0. And from where I find that 0, my final quotient of the function has x in the denominator. So I also have to give one extra condition. This x can be equal 0 because that will make our quotient undefined. So we're going to combine all of them together. So the domain of f over g is all the x's such that x cannot be equal negative 2, x cannot be equal 1, x cannot be equal 0. And using interval notation, if you will graph it, this is what we have. Negative 2, 1, 0. So that means you can pick any x you wanted except those three values. So this is domain, this is domain, this is domain, and this is domain. So using interval notation, you say from negative infinity to negative 2, union negative 2, 0, union 0, comma 1, union 1 to positive infinity. So this is interval notation. Okay, so that's it. So to find the domain of combined functions, combination, like product, sum, difference, find the domains of original functions, and they also will be the domain of your combination. And one extra part, when you have a quotient, like in part D, also check your final solution and give one extra condition that the domain of quotient, of course, it's domain of function f and domain of function g, but also check your final answer and give the condition, make sure that your denominator is never equal 0. So here we also had to give one extra condition that x cannot be equal 0 and combine them together. Okay, so that's it from section 3.1.